Now, let's move on to electron displacement effects. So, this is going to be one of the most important fundamentals for the organic reaction mechanisms. So, this is very vast, but it's pretty much easy to understand provided that you have your basics and fundamentals very clear. And this is highly application oriented. In every single reaction, the reactivity of the reagent could be explained in terms of these effects, more or less you could say, not every reaction, but at least these effects come into play in every single reaction. So, now these are called as electron displacement effects. You also call it as bond displacement effect. So, now let's try effect. Okay. Now, let's try understanding what exactly we are going to do this. Now, let me take a few molecules. Let's say if you have something like a hydrogen molecule. In the case of hydrogen molecule, two hydrogen atoms share their electron and form a covalent bond. So, that means in this case the electron pair is shared equally as both the atoms contribute. So, this is a pure covalent bond, and even when it breaks, hydrogen will take its own electron, the other hydrogen will take its own electron, and they would form a radical. Okay. So, now the similar case is going to be in the case of Cl2 as well. So, Cl2, it will be Cl pure covalent bond. Okay. So, again this is basically pure covalent bond. So, that means when you have a bond which is formed between two similar elements or two atoms of the same electronegativity, the bond is pure covalent bond. Now, let us take another case of HCl. Now, in the case of HCl, the bond is covalent when hydrogen shares one electron with chlorine, which has 7 electrons in its outermost valence shell, and this forms hydrogen chloride molecule. So, in this case, hydrogen completes a duplet with 2 electron and chlorine completes an octet because it is now surrounded by 1, 2, 3, 4, 5, 6, 7 and 8 electron. Now, if you know that chlorine is more electronegative because it needs just 1 electron to complete octet. So, chlorine is more electronegative. So, it will have the tendency to pull the electron pair towards itself. This would result in formation of a dipole, wherein hydrogen, electrons from this hydrogens will be slightly getting displaced towards chlorine. So, hydrogen would get partial positive charge and chlorine would get partial negative charge because the electron density would be slightly shifted towards chlorine. So, this would give rise to pole, or you could easily call it as polarization. So, what exactly do you mean by this term? So, this is what exactly is happening over here is polarization of a covalent bond. And why did this happen? This happened because there is a big electronegativity difference between hydrogen and chlorine. Hydrogen is least electronegative and chlorine is most electronegative. So, polarization happened. Now, this is basically the bond displacement effect. Here, the electrons don't leave their position, they don't leave their orbital, but they are slightly displaced towards more electronegative atom. So, let us define what you call it as bond displacement or electron displacement. It is a phenomenon in which I would write it is a phenomenon in which the electrons are shifted more towards more electronegative elements, and so it is a phenomenon in which electrons are shifted more towards the more electronegative element, or I would say shifted towards the more electronegative element. So, I would better use the word electron density, or more shifted towards the more electronegative element and leading to polarization of a covalent bond. Okay, so this is basically bond displacement effect, and this bond displacement effect normally would operate in many cases. There is one particular effect that operates only when there is a single bond. There are a couple of effects which occur only when there are multiple bonds. So this was about the basics of bond displacement effect. Now we will be moving on to a discussion on inductive effect, electromeric effect and all other different types of bond displacement effect.